Welcome to part 10 of this Python course, which deals with the generation and manipulation of random numbers. Now, they like to call it random numbers, but unfortunately, because of the generation happening on a computer, these numbers are not really random. They are something which is called pseudo-random. Now, what this means is that all random numbers are generated using a mathematical algorithm. So it uses a specific calculation. Because of a calculation being done, there needs to be a starting point, which is called a seed. Now, the seed is the starting point that the random number generator works on. It's a number which then is used to calculate another random number. But what this means is that if you use the same seed, then every single time the same random number will be generated, which means that it's not truly random. The definition of a random number is a number that cannot be predicted. By default, the random module in Python uses the current computer's system time as the starting point or the seed. So let's have a look now how we can actually generate a random number. Before we can use this random module, we need to import it just like we've done with previous modules. So we say import random. Once we've imported it, we can then go ahead and use the functions that are built into random to generate our own random numbers. So what I'm going to start with is the first method, which is called random. Now, what the random method does is it generates a number in the range from 0 to 0.999 recurring. So let's have a look how we can use the random module to import or to generate a random number. If I simply type print random dot random. All right, let's have a look here. This first random is the module. The second random is the method we are using. So if I ask it to use the random method from the random module and display it on the screen, if I run that code, we get an answer of 0.62656. If I run that code again, we now get 0.66659. And if I run it again and again, you'll notice that every time you run that method, a different random number is generated. Let's have a look at what happens if we introduce a seed. I'm going to say random.seed, and I'm going to put a specific number as the seed. I'm going to say I want you to use a starting value of 1 as the seed. And if I run this now, we get an answer of 0.13436. And if I run it again, we get an answer of 0.13436. All right, so let's put together a little bit of code to generate a certain number of random numbers. So I'm going to say for I in range, let's generate 5 numbers. And I'm going to ask it to print them out. Print random.random. So if I run that, we end up with 5 random numbers. And again, you'll notice that every single number is different. Let's change that to 10. And we now have 10 random numbers, all in the range from 0 to 0.999, and every single number, as you can see, is different from every other number that has been generated. The likelihood of 2 random numbers being generated to 10 decimal places in Python is extremely rare. All right, so let's have a look at another little example. What I'm going to do here, let's generate 10 random numbers and write them to a list. So I'm going to generate 10 random numbers and I'm going to save each random number to a list. Let's use 3 decimal places. How are we going to do this? The first thing we do is to create a list. We are going to be writing all our random numbers into a list, so we need to generate an empty list. So I'm going to call it LSTR for random, and I will make it a blank list. Now we can generate a loop. So for I in range 10, and then inside the loop structure, we can say lstr.append. We are adding each value into the list. What do we want to append? Well, we want to append random.random. But remember, we want to use 3 decimal places only. So I'm not interested in all these decimal places that are shown in the example above. I only want to generate 3 decimal places. So I'm going to round off each value 3 decimal places. So there we go. So I've run that code now. So if I print out that list, if I say print LSTR, we end up with the 10 values that have been generated inside the list. If we want to generate a number in a specific value or in a specific range, we then come to a different function, a different method, which is called, get it here, uniform. A uniform method allows you to generate a random number, which is a floating point number. So it generates a floating point number in a specific range. And that range will be from A up to B. So whatever values you put for A and B, a random number will be generated in that range. All right, so let's generate a whole lot of numbers and do some work with them. So I'm going to say LSTR equals a blank list, and I'm going to create a loop structure for I in range. I'm going to generate 100 values. And then LSTR.append, and I'm going to grab hold of the random numbers .uniform, and this time I'm going to generate random numbers from, let's say, 10 to 20. I also want to round them off just so that they're easier to view, so I'm going to say round to 2 decimal places, and then I simply want to display the LSTR I'm going to print out. So if I run this, you can see what happens. A list has been created consisting of 100 values. Because we've got a list, we can do some maths on the list if we want. So I could come in here and I can calculate the average. So the average of that list will be the sum of the list divided by the number of values in the list, which we know is 100. But if you didn't know how many values were in the list, we can use the length of the list. And I can then print that out. For example, I can say print the average value equals, round it off to 2 decimal places, format AVG. All right, and I can take out that last line because we don't want to display the whole lot. So if I run that now, we can see that we've still got this list being created. It's not being displayed anymore because I took it off. In fact, if I add it back, we'll see it just now. But there it's calculating the average value of all those values in the list. If I run it again, there's the average value, 14.77. If I run it again, we have an average value of 15.16 and 15.24 and 15.37. So you'll notice that the average value is always somewhere around a value of 15, which is halfway in between a value of 10 and a value of 20. So again, just to recap, the uniform method in the random module generates a floating point number in a specific range, and the range is specified using the two values A and B. The next method is another method of generating a random number, and this is called Randint. Now, Randint generates a random integer. Again, we specify the range A and B, generates an integer in the range from A up to B. Some code to simulate the roll of 2 dice. Let's start off by importing the module we need, which is random. The next step is to generate a list. I'm going to call it LST dice, and it will be empty to start with. And then I'm going to create a loop structure. For I in range 2, because we only want this loop structure to run twice. Remember, we want to generate 2 numbers to simulate 2 dice. Then I'm going to say LST dice dot append random dot randint, and the values we need to append are going to be from 1 up to a value of 6. All right, so let's have a look what is going to happen. Every time this loop structure runs, which is twice, it's going to generate a random integer in the range from 1 to 6, which is exactly like the numbers on a die. And it's then going to add those into the list called LST dice. And then if we print it out, I'm going to say print the dice roll, and we'll display the list. So format LST dice. So if I run that, it comes back and says, right, well, the 2 random numbers that were generated was a 1 and a 2. Just to make sure that it's not just choosing arbitrary values of 1 and 2 each time. If I run that again, it now comes back with a 5 and a 1, and then a 4 and a 6, and then a 2 and a 4. Okay, so I'm going to say include inputs on how many dice and throws to have. So let's write a full program. Starting off with import random, I'm going to create a variable which is the number of dice. That is going to be an integer value. I'm going to use input, and how many dice do you want to throw? Then we need to ask another question. Number of throws is equal to another integer value, input, and again we ask a question, how many throws do you want? Those two questions will allow the user to tell you how many dice he wants to throw and how many throws they want to have. And now we can set up our loop structures. For I in range, the number of throws. And then we're going to generate a list of dice. So LST dice is equal to a blank list. Next, we set up another loop structure for the number of dice we want to throw. So I'm going to say for J in range, num of dice. And then finally, we can now generate those numbers and put them into our list called LST dice. So LST dice dot append random dot randint, and again the range of values we want to generate will be between 1 and 6, or from 1 to 6. Finally, we can print it out. So I'm going to say print with dice roll format LST dice. Okay, so inside the loop structure, which is running through the number of throws, each time it generates a set of numbers, it prints out the dice roll, and then it does it again, prints out another dice roll, depending on how many throws you've asked it to do. So let's run this code and see what happens. If I run it, the first thing it does, it says, how many dice do you want to throw? Well, I'm going to throw 3 dice. And it says, how many throws do you want? And I'm going to tell it to have 5 throws. So what it's going to do is it's going to generate 3 random integers 5 times. So when I run that, it comes back and gives me my throws. So my first dice roll was a 6, a 4, and a 1. Second one was a 6, a 5, and a 3. Then a 1, a 3, and a 3. A 1, a 3, and a 1. And lastly, a 4, a 1, and a 6. All right, now we're going to get into a few methods which allow us to work with random numbers based on specific sequences. And the next method is something called choice. Now, what the choice does is it returns a random number from a sequence of values that already exist. So if you've got a list already which contains random numbers, we can then ask it to choose from that list of numbers. I'm going to import random, and then I'm going to generate a list of values. I'm going to say LST numbers equals X for X in range. Let's generate numbers from 1 to 20. I'll print that out. We'll see what it contains. LST numbers. So there we have a list. I've generated a list of numbers starting at 1 and going all the way up to 20. So it's basically just a list of counts. Now, I'm going to add some more code in here. I'm going to put some code in there to choose 5 numbers the list. How do we do that? I'm going to put together a loop structure for I in range 5, and then I'm going to say print random dot choice. We are choosing them from our list we created called LST numbers. So if I run that now, we can see that our original list is still there, which contains all numbers from 1 to 20. And this random.choice has now chosen 5 numbers from that list. And the numbers it chose are 10, 4, 14, 8, and 17. If I run it again, it again chooses 5 numbers from the list. 18, 7, 11, 11 again, and then 17. Thank you for watching, and please subscribe to the channel for more content.